Is hydrogen bonding. Nitrogen, oxygen, fluorine are electronegative elements, and here they are attached to the hydrogen atom to form covalent bond. Hydrogen bond is weaker than the covalent bond. Hydrogen bond is weaker than the covalent bond, and example is HF bond of hydrogen bonding. Next we are given that two atoms which holds one atom. Here hydrogen bond acts as a bridge between the two atoms which holds one atom by covalent bond and other by the hydrogen bond. Hydrogen bond is represented by the dotted line, while a solid line represents the covalent bond. The hydrogen bond can be defined as the attractive force which binds to the hydrogen atom of one molecule with the electronegative atom of the another molecule. Here it is given that when they are attached to the hydrogen atom, when they are attached to the hydrogen atom to form covalent bond, the electron of covalent bond are shifted towards more electronegative atom. The partially here hydrogen is having positive charge and halogen is having negative charge. The bond given. The magnitude of hydrogen bonding depends on the physical state of the compound. It is maximum in solid and minimum in the gaseous state, and hydrogen bonding has strong influence on the structure and properties of the compound. Types of hydrogen bonding: there are two types, inter and intra. Intermolecular hydrogen bonding example is HF, hydrogen fluoride, and alcohol or water. These are also intermolecular hydrogen bonding, which means it is formed between two different molecules of the same or different compound. And next is intramolecular, which means that hydrogen bonding in between the two highly electronegative elements present within the same molecule. For example, orthonitrophenol, the hydrogen is in between the two oxygen atoms, and intramolecular hydrogen bonding in orthonitrophenol. Next, it is given that type of overlapping and the nature of covalent bonds. First is sigma. This type of covalent bond is formed by end-to-end or head-on overlap of the bonding orbitals along the internuclear axis, end-to-end overlap and along the internuclear axis, and it can be SS, SP, PP. Next is pi bond. Pi bond, it is the formation of pi bond. The atomic orbitals overlap in such a way that the axes remain parallel to each other but perpendicular to the internuclear axis. Parallel to each other and perpendicular to the internuclear axis. In sigma, it was along the internuclear axis. Next thing, the orbital formed due to the sidewise overlapping of the two soccer-shaped charge clouds above or below the plane of the participating atom. And next, strength of sigma and pi. In case of sigma, the overlapping takes place to a larger extent and hence it is stronger as compared to the pi bond, where the extent of overlapping occurs to the small extent. And next, further, it is important to note that the formation of multiple bonds between the two atoms of a molecule, pi bonds, is formed in addition to the sigma bonding. So sigma is stronger than pi because the extent of overlapping is more. And next, it is given that hybrid orbitals, hybridization, and a salient feature of hybridization is that number of hybrid orbitals is equal to the number of atomic orbitals that gets hybridized. Second is that the hybrid orbitals are always equivalent in energy and shape. Hybrid orbitals are always equivalent in energy and shape. Third one is hybrid orbitals are more efficient in forming stable bond than pure atomic orbital. Hybrid orbitals are more effective in forming stable bonds than the pure atomic orbital. Next, fourth one is that these hybrid orbitals are directed in the space in some preferred direction to have minimum repulsion between the electron pairs and thus stable arrangement. Therefore, this type of hybridization indicates the geometry of the molecule. The hybrid orbitals are directed in a preferred direction to have minimum repulsion between the electron pairs and thus there is stable arrangement. Next important condition for hybridization: the orbitals present in the valence shell of the atom are hybridized. Orbitals present in the valence shell of the atom are hybridized. Next, second is that the orbitals undergoing hybridization should have almost equal energy. Third is that the promotion of electron is not essential condition prior to hybridization. Fourth one is that if it is not necessary that only half-filled orbitals participate in hybridization. In some cases, even the filled orbitals of the valence shell take place in hybridization. So revise once again. The first is that the orbitals present in the valence shell of the atoms are hybridized, not electrons. Orbitals, it is given that orbitals present in the valence shell are hybridized. Next, orbitals undergoing hybridization should have almost equal energy. Third is that promotion of electron is not essential condition prior to hybridization. And yes, and the fourth one it is given. Next we have yes is in s orbital directional nature is more, and in p orbital angular nature is more during the mixing. In sp2 shape it is given that the uh, the hybrid orbitals of a carbon atom overlap axially with the sp2 hybrid orbitals of the another carbon atom to form the carbon-carbon sigma bond, and the unhybrid orbital overlaps sidewise similar to the orbital of the other carbon atom to form weaker pi bond.